Alright, so we're going to turn to page 6 in our little quadratics book. Is finding roots. So basically we're going to set f of x equal to 0 to solve for x. So the difference between this and where we're just wanting to factor or multiply out the binomials is that it has an equal sign. If it has an equal sign, it's no longer just an expression, it is now an equation. So we've set our two binomials equal to 0. In this case, we already have our factored form, which is what we want for these kind of problems. So we're going to set each binomial individually equal to 0. So we have 7x plus 1 equals 0, and x minus 5 equals 0. So on this one, we're going to have minus 1 on both sides. So we have 7x equals negative 1. Divide both sides by 7. You get x equals negative 1/7. Now we're going to look at our other side. We have x minus 5 equals 0. Add 5 to both sides, and then you're done. X equals 5. So our solutions are x equals negative 1/7 and x equals 5. Now let's try another example for this. So finding roots, example 1. So go ahead and pause the video, see if you can find these yourself. Remember, set both of the binomials equal to 0 individually. Okay, so we set up your two equations. You have x minus 3 equals 0 and x minus 4 equals 0. So we're going to solve each of these. So add 3 to both sides. X equals 3. And let's solve our other side. Add 4 to both sides. X equals 4. So our solutions are x equals 3 and x equals 4. Okay, let's try another one. This time it's not factored for you already, so you have to go and factor it first. So go ahead and pause the video, see if you can remember factoring this right here before you find your roots. Okay, so now we're going to factor. There's no number you could take out of all three terms, so you just end up with this. So we're going to multiply a times c. That's going to give you 4. Our b is a negative 4. Now we're going to find factor pairs that multiply to give you 4 and add up to give you negative 4. So we have a negative, so we know that we must have two negatives. So negative 4 times negative 1, and negative 2 and negative 2. Well, negative 4 plus negative 1 is negative 5, and that's not our b that we want. Let's try the other one. Negative 2 plus negative 2 is negative 4. If you ever come across a situation where none of the factor pairs actually work, then that means that this is not factorable, and we'll use an actual different equation to find it. You'll see in a later video. So let's go ahead and decompose our b into a negative 2 and a negative 2. So let's write out our box terms. So we have 4x squared, and then we have our two b components, negative 2x and negative 2x, and then our last term, our c plus 1. Okay, let's see what we can pull out of these two terms on the first row. They share 2 and they share an x, so we're going to put 2x right here. Okay, divide 4x squared by 2x, you get 2x. Divide negative 2x by 2x, you get a minus 1. Okay, so now what times 2x gives you a negative 2x? That would be a negative 1. So we're going to write out our factored form. 2x minus 1 and 2x minus 1. And then don't forget the equals 0 because it's now an equation. Since these two binomials are exactly the same, we could rewrite that as 2x minus 1 squared equals 0. To get rid of the square, we're going to square root it. Okay, square root of a squared, you're just going to have 2x minus 1, and then the square root of 0 is just 0. Notice we're only going to have one unique root. Add 1 to both sides. So now we have 2x equals 1. Divide both sides by 2. X equals 1/2. And since we only have one unique root, we can say that this x equals 1/2 has a multiplicity of 2. It's one of those situations where the parabola touches the x-axis only one time and then it goes either back up or back down.